Now let's look at some truth tables. So let's write down the truth table for the conditional statement P, if P then Q. So here I have two statement variables, P and Q. So my truth table will have 4 rows. So now I'm ready for my conditional column. So here in the first row, they're both true, so the conditional statement is true. But in this second row, the hypothesis is true and the conclusion is false, so that would be false. And then in these last 2 rows, the hypothesis is false, so the conditional statement is going to be true. So that's the truth table for if P then Q, the conditional statement. What about the truth table for the biconditional statement? So again, our truth table will have 4 rows in it. And now the rule for the truth table, because it's a biconditional statement, they have to have the same value. So they either have to be both true or both false to write down true. So in this first row and the fourth row, they have the same value, so those will be true. But in the other 2 rows, they're not the same, so those would be false. All right, so let's work on creating a more complicated truth table than those. Let's construct the truth table for the statement P or not Q or Q. So again, I have 2 statement variables, P and Q. So my truth table has 4 rows. And we build up to our statement. So I see that I'm going to need not Q. So let's write that column down first, not Q. You flip the entries of Q. Now I'm also going to need this larger statement here, P or not Q. So that will be my next column, P or not Q. So I'm going to look at the P column and the not Q column, and it's an or, so you just need one of them to be true. So it looks like I got true, true, false, true. And then for our final column, we need P or not Q or Q. So now, which columns are we going to look at? We're going to look at the last column we just made, P or not Q, and we're going to look at Q. Again, there's an or between them, so just one of them needs to be true. So I'm getting true, 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 true. So I have a column containing all true values here. And remember that that has a special name. It means that my statement is a tautology. So let me remind us of those terms. A compound statement is a tautology. If it is true for all possible combinations of truth values of the component compound statements. So basically, if in my truth table, it contains all true outcomes. The only possibility is that the statement is true. So again, our last example, our last problem we did, that was an example of a tautology. On the other hand, if you have a column of all false, it's called a contradiction. So a compound statement is a contradiction if it is false for all possible combinations of truth values of the component compound statements. So I'll give you an example here of one that is a contradiction. P and not P is a contradiction. If you fill out the truth table for this statement, you would see that the column contains only false entries.